team. I guess while people are setting up, why don't you give us a bit of background, famous robotics.
All right. Well, this year we tried to do something a little different that's never been done before, due to something that we really saw that was wrong with the robots last year. And that's really that the frame rates are kind of low. You've heard Ben and some of the other teams talking about low frame rates before. You usually get around maybe a total sensor up to This is fantastic. I didn't ever anticipate this kind of performance at this point. It'll time out. It'll time out.
All right, so again, this is the stunt detection that we talked so much about.
Where's the timeout sequence?
It's supposed to time out. I don't know what to tell you. Well, if it were moving right now, it'd be seeing at a whopping 60 frames per second and updating its sensors fairly quickly. You'll see it straights off the sides of the course a little bit pretty nicely. It's really good at long, narrow corridors. And part of that is because most of the teams don't have access to really high update rates with the sensors and with the camera. But by updating at a much faster rate, it allows us to behave that way.
So again, this team, we very generously, I think, gave them a computer and a North board and all of that, and they said, ours are better. Built their own. So this is a robot that truly is entirely from scratch. Whoa. It's now we're experiencing a bit of problems getting around.
Well, this morning, our original gate dispense mechanism involved a passive gate that would let balls in, and it had 3 modes: totally open, closed such that you couldn't push in from the front, but it could push balls. Come on! And so just this morning, we were playing with the gate code because it was broken. The gate was broken, the passive gate. And we spent some time fixing it, and it appears that the way we fixed it just didn't hold, I guess. The idea is that the gate should be passive so that balls can roll in but not out. And we tried to make some last minute modifications so that we could push balls into the gate, and those modifications appear to have failed. But it doesn't look like it's going to score with the broken gate, but you can see that using the FPGA and using the microcontrollers have given us enough speed to do something very different to pick up balls really fast.
So your motors are also able to move incredibly quickly. Your robot in general seems very agile. What do you attribute that to?
Right. So that was kind of a problem we ran into in the beginning. Since we weren't using the board of the computer, Oki, our resident analog hacker, took it upon himself to build his own motor controllers. And they're basically current amplifiers that take PWM signal in, which is just kind of an analog-based digital signal. You can code it, a number from 0 to 255 with it. And it produces some current output to the motors that allow it to move. And Oki made ones that were more powerful than the ones on the York board. And we were hoping to really push them to the limits. But unfortunately, the motors that we were given are high speed, not high torque. And so there was not enough torque being output of the motors, no matter how much current you ran through them, to actually make the robot move. So at the last minute, about 40 hours ago or something, we geared the motors up so that it would move without being overstrained, and we geared them up too much. And so now it's going a little bit slower than I know it could.
So just a rough estimate, how many amps will each motor draw on the whole board?
Well, we have 24 volts going through the whole thing. We use 2 batteries. And it used to be that the motors would draw about 2 or 3 amps each because they were really being overdriven, which is way too much. But I would suspect now that they're being driven under no load because the gear ratio is so high that they're probably pulling about a half an amp each or maybe less.
For those of you that don't know, that's quite a bit of amperage to be putting through just one motor on a robot this size. You can see it in just the speed that it goes. So moving on, this camera is able to process 60 frames a second.
Right.
So what's the reason for that? Why is this so much faster?
Well, one of the things that we're doing to pick up balls is we're PDing, which is an element from control theory that allows us to line up to the ball and eat the ball at the same time. So we don't have to stop, line up, and then move forward. We can literally go at full speed straight into the ball and pick them up. And you can see the evidence of that in the beginning when it was picking up so many balls so quickly. And that's really only possible when you have a high frame rate. But now it seems like we're not retaining balls since the gate is broken.
So the high frame rate then is just a feature of the camera and all of that.
Well, no, it's a feature of both the processing and the camera. The camera is a normal analog NTSC CMOS camera. So it's just like a similar output to what you have from your video camera, but instead of using a USB channel, which jumps entire frames at a rate of about 20 frames per second, and then gets processed in a computer, instead we have the actual pixel data coming in line by line. If you're familiar with how a CRT TV, like in your house, works, it actually scans each of the pixels line by line. And we do a similar, all our processing in that similar scan-wise. So we start at the top left pixel, scan the first line, and then go down and scan the second line.
All right, well, it seems like you guys have completed your own successfully. So given the close nature of some of these balls, we need to determine whether or not they are in fact 12 inches from the porch. So we have one ball on the porch. And one in possession, so that's a total of 3 points. I can't emphasize my disbelief enough that this team was actually able to move. At the beginning, they told us, we're not going to use the orc board, we're not going to do this. And the staff kind of said, you're insane. And they are, but they managed to do a fantastic job. I think it's really just a testament to, I guess, what some MIT students are capable of if they really set their minds to something. So, looks like we've hit another slight snag here in